This is for Year 11 methods. We can look at question 16 from exercise 18E. A piece of string 10 meters long is cut into two pieces to form two squares. So if I have a piece of string, I cut it into two pieces. These four pieces are meant to form, well, these four pieces are meant to form a square, and these four pieces are meant to form a square. Now, if one piece of string is x meters, and the other would be 10 minus x, each of these pieces would be x divided by 4. Okay, and these pieces would be 10 minus x divided by 4 per piece. Okay, so we have a scenario where we have x divided by 4. X divided by 4 is my first square, and the second square would be 10x, 10 minus x divided by 4. 10 minus x divided by 4 as my second square. Now, we want to show that the area is given by that. So we know the area is given by the area of the first square, which is x on 4 squared, plus the area of the second square, which is 10 minus x divided by 4 squared. Okay. So simplifying, we get x squared on 16 plus, okay, if we expand that, we get 100 minus 20x plus x squared over 16. Now, what can we do? We can combine the tops, so 2x squared minus 20x plus 100 on 16. I can divide the top and bottom by 2, so we'll get x squared minus 10x plus 50 on 8, which equals what we're after, x squared minus 10x plus 50. So that's my show that. And part B, we're trying to find dA dx. So dA dx is given by we can essentially leave the 1/8 out. It's 2x minus 10. Okay, so it looks like that. So if I were to simplify that, that would be x on 4 minus, x on 4. Or I can take, actually, no, I can take a factor of 2 out. So that will be a quarter x minus 5, which would be my dA dx. So we've done that. Find what x value makes a minimum. So we want this to equal 0. We want dA dx equals 0. So x equals to 5. What makes the total area of the two squares minimum? Well, first of all, we know it's a minimum because the original is a quadratic. It's a frown. It's a smiley face. So it's going to be a minimum. So we know this is a minimum, and we want to find what makes the total area of the two squares. What's the minimum total area of the two squares? So the minimum would be the area minimum would be given by when we sub in 5 into the equation. So 1/8 25 minus 50 plus 50. So cancel. It'll be 25 on 8 meters squared is the minimum. Now you can do this on the CAS calculator, but for whatever reason the numbers aren't too bad, so you can do it by hand if you want to. So hopefully this helps on getting how to get firstly the equation, then deriving it, setting it to equal 0, and then subbing in the minimum value.